So what you'll see in today's video is the tutorial of how I created these structural members. Now I start by showing you how to create the base geometry and then develop something like this, where we can now change, let's say, the spacing of the structural members. We can set any curve to set that structural member, but at the end I also show how to turn that into a truss system. So also showing you how you can edit a base script and add more details to it. So I'm enabling this one. It takes a little bit for it to calculate the Boolean difference in Boolean union. But once it does that, it creates the same member, but now it does it with a subdivision. So I'm going over all the steps here, and I'm also sharing with you another bit of what I created. Just showing you the range of different things you can create. Taking the same steps that I'm showing you, you can take similar steps and create other details of other variations that may be more suited to whatever you're trying to do. So that's kind of the goal here, is to show you exercises, showing you techniques that you can apply to your own designs. So thank you for being here. If you want to download this, check it out on my website, capettidavid.com. Let me show you these other applications that I created for this. All right, so I wanted to show you the pack of structural members that I have on my website. What I have here are these scripts that are organized into clusters. Now I've also applied a base surface like this, but as you can see, we have all of these line segments that are turned into beams. The beam is also offset. So you have the outside material, then you have the beam system that connects onto the outside structure, and then these that will support the skin or the outside covering. So I created this first one, which is the roof cover, this other one, which is the outside fascia detail. Then on this one, I used the I-beam, which is similar to the tutorial that I'm showing you today. And then the last one were these members that are sitting right on top of the I-beam that support the roof like I showed you. So now let's get into it. All right, so what I'd like to do is bring in the base geometry, but before that I like to bring in a scale person and start with that so I can visualize the scale of the object. All right, so now the base geometry needs to be a line segment, but the line segment would be better if it's not just the straight line segment. It's better if it's an arc. So starting here, I'll create an arc or a point, and we'll start here with construct point. So now using this point, we're going to move it in the X direction. So move in the X direction. And I'll use a slider here. I'll say 48. Or let's say 100. And then we'll take that same move component, we'll copy it down here, tapping Alt, and now I'll actually do divide by 2. So this point will actually be moved halfway. What I'll do is then take this point and move it up again, rather than in the X direction. This way I can create 3 points, and with those 3 points I can create an arc and use that as a base geometry. So using this Z vector and creating an arc between the start this is going to be an arc with 3 points. So starting at the start point, going through to the C point, which is the last one, and then the one that we moved up is going to be B. So now we can change the length and we can change the height here. So let's change actually the max to, let's just say 5. Okay, now let's create an array in the Y direction. So I'll bring in a component called linear array. We'll be using the arc as the input. The direction is going to be the Y direction, and we can pick the spacing by plugging in the factor into the direction and then the vector into the direction here. Now the count is how many, so let's go here to 3. Let's decrease the spacing. Okay. So now with this, we've kind of set some base forms that we can apply. Now let's develop the design here. So with this, we'll bring in a curve component. Now that it's here, I can disable it all the way back here. Now we can always bring those back and use them again, but for now, now that we have that done, let's move on and start developing this. So first thing is we're going to offset this curve. Now when you offset it, it tends to go up and down because it looks at the plane that creates that curve as the way that it's going to offset it. So we need to change that to an XY plane, or a plane that is located horizontally. We can use this as the plane input, and now offset this by, let's say, 3.5 in the positive. And then I'll copy this again, tapping Alt, and creating a negative offset. Basically taking this and using that as the center line, which means that 3.5 has to be divided by 2. Otherwise, it's going to be 2 times 3.5. So when we divide it by 2, we can account for that. Now we can use this slider as the width of it. So 4, 6, now to bring these two together, we can loft them. Sometimes loft doesn't work, so I'm going to show you 2 different ways. If loft doesn't work, which sometimes it doesn't, you can also use, so this is one option. You can also bring in the endpoints for both of these and create a line segment between the start points, creating it here, and the endpoints. And you can use a network surface component using these as the U or V. So let's say these will be in the U and these will be in the V. So these are 2 different ways that you can create a surface. Now this one is a little bit more elaborate, but what happens is sometimes when you have a curve that's doing weird things, you may not be able to loft it together. So in terms of ease of use, let's just keep it here with this loft. Okay, next what we're going to do is move this loft down to create the height. So now let's go to move, this loft in the negative, so down, Z, and we'll use a slider here for the heights. So we'll do 3 less than, let's just do 1 less than 6 less than 36. That's 6 inches. We can always change that here. Now, not only do we need to move down the loft, but we need to move the line segment down. So what we have are 2 line segments that need to be lofted together. So I'll copy this loft, or I can bring in a new loft component and plug these 2 in. This one and this one. Now notice that they're not organized correctly. So when we graft it here, so let's try graft and then graft. So what's happening here is how things are organized. It's not necessarily working, or they're not organized correctly. So what we're going to do is plug in this curve into a graft tree and use both of these. We'll use graft tree on that one, graft tree on this one. This one. We have to graft both of those. I'm using it as a component. You can also right click here and graft, but what happens is that one has some multiple outputs and I don't want to mess that up. So using graft tree here will fix that issue. So here we have now the base geometry in terms of surfaces. Before we started with the line segments, now we have surfaces. Now we need to extrude them. So here are some things to keep in mind. All right, so before that, let's go here to wire display hidden, and try to keep things organized so we don't get lost. One of the things that is tricky about creating the scripts is staying organized enough to where you can find your way back around and be able to change your script by knowing what you did within the design. So with this, let's take these 2. Now we're going to extrude them. So let's go to an extrude component. We're going to extrude that down. Now I'll use here a extrude, then we'll use 0.25. Now notice this is extruding down, and the reason why is because when we set this curve, typically you'll want it to be the center line either at the bottom or at the top. Here I'm actually setting it at that the beam is created below it. Why? Because let's say you have a roof and this surface that you create those curves on is the surface is at the top. Well, you want the beams to be below so it can support it, but we can also make it so we can shift where that is located for it to be either a flush beam, a drop beam. So those are the things that kind of come to mind here. But with that, we extruded that down, let's say by 0.25. Let's make it a whole inch. Let's say we extrude that down by 1 inch. We're going to do the exact same thing to the one at the bottom. Now we can pick a different slider for them, but let's keep them the same. Now notice that when you extrude this one down, it intersects with that surface, and when you extrude this one down, it doesn't. Now let's take this and move it down half of this. So if this is going down by 1, we'll do it by 0.5. We can do divide by 2. And I've also learned another way of doing it. Like if we bring in a number, and we bring in this number, and we just do expression x times -1. That can also give us, or times 0.5. That's correct. That can also give us the result that we want. But what I'm going to do is just use the divide by 2. Because now, whatever height it is, it always sits in the middle, and that's going to be useful when we use Boolean union to bring it all together. So let's take this and now offset it. We'll do offset surface, because what we need to do is turn this into a solid. Now we can move it in this direction, but when you move it, you need to tell it in what direction, and we would need to pick a plane that is relative to that surface. Or when you offset it, it's always going to offset perpendicular to the surface. So when I plug this in, I'll go to 0.5, let's say 1.5. And then -1.5. We'll bring this back down to 1. And in the same way that earlier we used it as a center line, therefore when we offset to both sides, we'll divide by 2 to get the true overall offset of 1. And therefore, being consistent with this one, so we can just use 1 if we want to, and they will all change at once for the same thickness. So let's hide the middle one. And now to finish this off, to turn it into a solid, first I'm cleaning this up a little bit. We need to take this loft and create a surface between those two for that offset and that offset. And now we're going to loft it together between this one and this one. Notice that it creates kind of that ribbon all the way around. Which now we can use a join brep, and using this, and this, you can flatten the input. So I'm holding down shift, or let's see, I'm holding down shift to add another input, and then hide the input here just so it's not overlapping. Notice now that that is a solid that we can offset. That's going to be, oh, we use this number now. That is tied to both of those at once, which obviously we can change. There's this, and this. Okay. So now using those, let's bring them together using union. Solid union between the top, the bottom, and the middle. Now I will, if you look here at the end, you'll see it has 9 different ones, which means that they're not together yet. When you flatten the input, you'll get 3 different objects, which is correct. And now, to get rid of the creases in between here, so you'll have, just by a matter of bringing everything together, you're going to get a crease. Now that's fine, it's not that big of a deal, or you can use a merge faces to clean it up. And now let's hide the wires on this. And so let's go back and change this, or even add more. So the idea is that we can set any curve and be able to create these structural members, saving you time and also allowing you to pick the size of what this is going to be, because we have the height, we have the overall depth. We can change it for this to be its own. There you go. Okay, so that works with that. I'm going to bring in a custom preview so we can see it a little bit better. So custom preview and a color swatch. Now let's do one more thing. I'm going to show you, now that we have kind of this created and we can set any curve, let's also show you that we can take these three we can bring in an empty curve component, set multiple curves, and then use those as the input. Now what I'm going to do right now is save this because I don't want to lose it. But once I do that, then I'll try this and then I'll show you how you can apply it to anything. All right, let's give this a shot. Now let's use graph. Now for some reason the color swatch is not working, but yes, this is working. And we can change the direction of this one independent of the other ones, and it will still apply it there. Now, for some reason, now it's working for some of those. The color, maybe it's something with the object. But this is super useful. So I'll delete this for now. Bring back our base geometry. If graphed, maybe it's without grafting it. Just going to try this one more time. Yep, it works. Okay. So clearing that using this. Now let's go back and edit this. So looking at one other thing that we can do is when we create this loft between this offset, so there's this, then there's this line segment that is created by moving that down. One. Okay, this one, and then we're going to see how that gets moved down here. So now we're going to take this one and extend this. So let's go to an extend component and use a negative component to shorten that arc. Let's go to 24. A little bit too much, so let's bring this back. And now we'll loft this one instead. Notice that it actually kind of shortens it this way. Now, the issue that that brings in is that we brought this one down rather than created it independently. So what we need to do is recreate this. So this one, we need to delete it. And rather than moving that one down, we're going to move taking the new one, and we need to do the whole offset thing. So offset in law using this, and hide the wires here, otherwise it just gets a little bit messy. The reason why this happens is because I tend to borrow a lot of sliders from earlier on, tying it all together. What that does is this. Now that we have this one, now we can take that one and extrude it down the same way that we did it with this one. So it's the loft, right? And extrude down using this one. Now notice that it intersects with it here at the end here, and I think that's okay. So notice that sometimes when we change the script, there are other things that we need to change depending on how you organize it. This time how I organized it was I just took this one and I copied it down. Well, what I had to redo was, no, this one had to be done independently. So we can use this curve that can get shorter, and therefore allowing us to kind of create more, what would you say, more of a dynamic design and having more options. Everything is pretty organized here. All right, so let's move on to the next modification that I want to show. In the files that I'll be sharing, you'll see this script and you'll see some other ones, which will be useful because when you create a structure, you want to have different kinds of variations. You won't always use, let's say, an I-beam. Sometimes you'll use a truss, or sometimes you'll use a, just a regular extrusion. I'll go back and hide a lot of this stuff. All right, so to create a pattern here, what I'll do is go back to where we have the surface. So this is where we have that surface, and that surface is then moved down. This surface now I want to subdivide, so I'll go to isotrim and, like always, divide domain squared. We can use that surface and subdivide it in the U and V count, letting us pick here the U and V, so how we want to subdivide this. And we can say let's say 3 on 3 and 3. we could take that and let's say offset this curve. So all of those surfaces have a curve on the outside, and using the plane, same plane as the input, and using the distance as a negative, because I can tell here that it's offsetting the wrong way. So I'm going to offset this, let's say 1.5. With this one, you can kind of hollow these out and then use a radius so we can fillet the edges of those squares. Why? Because it just gives us more variation. And in some cases, when you're using a CNC, you don't want to use perfectly rounded off edges. You want to at least use 1/2 inch or 1/4 inch. So using that, these surfaces, now we can take that surface and create a region difference. So subtracting those, so if it has 5 of these and it has well, we'll just flatten the V and it'll work for sure, but okay, so if this is a planar one, you can use boundary surfaces. So if region difference doesn't work, actually in this case it's going to be better to do it this way anyway, and flatten the input. And you'll see now that when I hide everything, including now we can use this as the surface. So taking this, let's see if we can offset that as well. I'll create a relay here so that way it can just use one input for the surface here. Now I do see that there's a few other things that are tied to it, like this other surface over here. But the reason why I create this relay and this is because now I can copy this and do it again, but for this one. Now the difference here is that you can't actually offset this. So the other way of doing, okay, no, this is a better way. And sometimes, you know, it takes, you know, working out the wrong way to do it, but we're now going to create boundary surfaces with this. I'm going to take this and extrude it or offset it using this, turning it into a solid. All of these into a solid. Now this messed up because this needs to be grafted. Between these two. in the same way that we did it with the other ones. Why? Because now that we have this solid, we can subtract it from this. It's going to be this one. We'll go to difference. Use that as the BREPS A and then this as BREPS B. Now we can hide the display. So here's the way that I like to look at this. We have two different options here. We have the first option, which is this one. I'll bring this into a geometry component here. I like to group it so I know that that's an output. Now we can also join together all of these, starting with this one and then moving into the next ones, just this one. Top, and then bottom one. So what do we have here? We have two options. Now we can separate these options as well, and you can create more variations. But the idea is that you have now this one, if we hide everything else here, which is a beam that has the cutouts for like a truss system, or we can also almost round this to a circle. Now, for some reason, we're not even able to see this in this. I'll bake it. Have no idea why it's giving me that issue. Or if like a visualized, oh, now it's working. Now we have this super clean beam that has those perforations. We have two different options. We have that option and we also have this option. And we can set any set of curves for this. So now what I'm going to do is clean this up. But before that, actually, and I wanted to show how you can set it to anything here. I'll bake this one. All right, so the next part that I said I want to show you is this. So we've got the stage set, so we can set any curve. Now, in a previous tutorial, I've shown how to create a surface or a sine wave surface. So you can set any surface here. Let's go to a plane. Just create a plane surface here. Kind of make it around the same size as this. Then I'll use cage edit, bounding box, or not even bounding box, rectangle, and use this rectangle here. U and V, count 6 this way and 6 this way. And then I'll take this one and move it up. Take this one and move it down. And overall, change this, say like this. I'll take the control, and I'll just delete it because it's going to give me an issue anyway. Now I'll take the surface and I'll bring it here into Grasshopper. I'll go to an empty surface component, set that surface. I'll pick the midpoint of that surface, so I'll need to bring in an area component to get the centroid. And using centroid, I can use a component called contour, which will let me set contours on this, so we can start at this point using this shape. In the direction, let's just say in the Y direction. Now let's change the distance. So this is going to be the spacing in between. Now you don't want to go too small. So now I'll actually set a limit of less than 6, less than 12, less than 48. Oh. Let's do that again. It's going to be 6 less than 15 less than 36. So it's going to offset by 16 inches, or let's just do 48 or 36. Maybe let's increase it to 60. And it's actually going to go into the distance. So what we're doing is setting the stage to create these line segments that we can decrease the spacing of, to be able to set those contours here. Now I want to start with less. Use those contours, plug them into this curve. Now notice that it will create those structural members at that location. And we can still change some of the edits here. So this only has 10 subdivisions. We can do more or less. So I'm changing the max count. And if you don't want this one, because sometimes it does take a lot to compute this, you can enable this one, and just know that we can change this to be, let's say, 48. And since it doesn't have to calculate the Boolean difference and Boolean union, it's going to be a lot faster. And you can even pull the slider like this, a little bit easier to see the changes here. All right, so now I will be cleaning this up and making it available so you know exactly how this all comes together. If you have any questions, let me know in the comments below. I have resources on my website that can help you learn how parametric design works, and it also will help you create things for your projects and save you a lot of time. So thank you very much for being here, and I hope to see you on the next one.